Imagine you have a book, a beautiful leather-bound collection of history. You throw it into a fire, and while the pages turn to ash, the information, the words, the stories is technically still there in the smoke and the soot. But what if you threw that book into a black hole and the universe simply deleted it? This isn't just a philosophical nightmare. It is the black hole information paradox, the glitch in the matrix that threatens to break all of physics as we know it. Welcome to Sci Nova, where today we are diving into the most violent argument in the history of science. On one side, we have general relativity, Einstein's masterpiece that explains gravity and the massive scale of the cosmos. On the other, we have quantum mechanics, the rulebook for the tiny, chaotic world of atoms. They both work perfectly in their own lanes. But when they meet at the edge of a black hole, they start a fight that neither side seems willing to lose. To understand why this is a problem, we first have to understand what a black hole actually is. For a long time, we thought they were eternal, one-way streets. Once you crossed the event horizon, you were gone. But the black hole itself remained a permanent scar on the fabric of space. However, in 1976, a physicist named Stephen Hawking changed everything with a prediction that shook the foundations of the scientific community. Hawking proposed that black holes aren't as permanent as they look. He suggested they emit a tiny amount of heat, a phenomenon we now call Hawking radiation. This means that over incredibly long periods of time, a black hole actually loses mass and slowly evaporates. It's a slow, cosmic leak, but it leads to a terrifying conclusion. Eventually, the black hole disappears entirely, leaving nothing but a faint glow behind. Now, here is where the catastrophe begins. According to Hawking's original calculations, this radiation is completely random. It only carries information about the black hole's total mass, its electric charge, and its angular momentum. It doesn't care if you threw in a library, a star, or a grand piano. The specific details, the information of what fell in seems to vanish with the black hole, leaving the universe's ledger completely unbalanced. This is the core of the paradox. In the world of quantum mechanics, there is a fundamental rule called unitarity. This is a fancy way of saying that information must be conserved. If you know the current state of the universe perfectly, you should, in theory, be able to calculate the past and the future. Information cannot be created from nothing, and more importantly, it cannot be destroyed. It's the ultimate law of cosmic bookkeeping. So, we have a massive contradiction. Quantum mechanics says information is immortal, but Hawking's evaporation suggests that black holes act as the universe's ultimate delete button. If the information is truly lost, then the entire mathematical framework of quantum mechanics is wrong. If the information is preserved, then Einstein's description of how gravity works at the event horizon must be flawed. We are stuck between a rock and a very, very dark place. Let's take a moment to look at the scale of this problem. This isn't just about losing some data. It's about the causality of the universe. If information can be destroyed, then the link between cause and effect is broken. The past becomes unreachable. The universe loses its memory. For physicists, this is more than a math error. It's a fundamental crisis of existence that forces us to rethink everything we know about reality. So, how do we fix it? Scientists have been throwing everything they have at this problem for decades. One of the most radical ideas is the concept of firewalls. This theory suggests that instead of a smooth descent into the black hole, there is a literal wall of high-energy particles at the event horizon. Anything touching it is instantly incinerated, potentially protecting the information by preventing it from ever entering the interior in the first place. But firewalls have their own problems. They break Einstein's equivalence principle, which says that an observer falling into a black hole shouldn't feel anything special as they cross the horizon. If there's a firewall, the smoothness of space is a lie. To avoid this, some theorists look toward the page curve. This involves complex mathematics, suggesting that as a black hole evaporates, the information slowly begins to leak back out through the radiation, encoded in a way that is incredibly difficult to read. Another mind-bending possibility is the holographic principle. This idea suggests that the three-dimensional volume of the black hole might actually be a projection of information stored on its two-dimensional surface. Think of it like a credit card hologram. The inside of the black hole might just be an illusion, and all the actual information is safely etched onto the event horizon itself, waiting to be radiated back out. This brings us back to the central conflict, the bridge between gravity and quantum mechanics. We are essentially looking for a theory of everything. To solve the paradox, we likely need a new way to describe how space and time themselves are built. Many physicists now believe that space-time isn't a fundamental thing, but rather something that emerges from the entanglement of quantum information. In a sense, information might be the bedrock of the universe. The search for the answer is far from over. We are currently waiting for better observations, perhaps from gravitational wave detectors or even more advanced telescopes, to see if we can find clues in the way black holes behave. Every time we study these cosmic monsters, we aren't just learning about gravity. We are learning about the very rules of existence. The paradox remains, but it is also our greatest guide toward a deeper truth. The black hole information paradox is a reminder that the universe is much stranger than we can imagine. It's a puzzle that challenges our logic and forces us to expand our minds. If we can solve it, we might finally understand how the whole cosmic machine actually works. Thanks for watching SciNova. If you enjoyed this deep dive into the void, make sure to hit that subscribe button and join us as we explore the next mystery. Keep looking up.